Okay, final installment for ChemQuest 27. We'll be doing the last 3 questions on that last page. Skill practice numbers 4 through 7. All right, moving on. Number 4. So we're moving on to empirical formulas, right? And combining that with that concept of percent composition, molar mass that we've been working on. Okay, so this would be kind of one of those last couple sections from the critical thinking. This is practice, so I'm a little faster with a little bit less explanation than what I did previously. All right, so we know that we have a compound that contains 25.9% nitrogen and 74.1% oxygen by mass, right? And we want to determine that empirical formula. All right, now this is probably the longest process of anything for practicing for topic 6.2. And that there's lots of steps, and it's easy to get lost in the shuffle. All right. The first step, right? We're going to divide the percent by the molar mass. Okay. So in this case, for each individual compound, that's just going to give us a number. So I'm going to go for nitrogen. I'm going to go 25.9 over the mass of nitrogen, which is 14.01. That comes from the periodic table. All right? And that is going to give me a number that won't have much meaning just yet, 1.85. Okay? Now, we're 74.1% oxygen, so I'm going to go 74.1 over 16.00, and this is for oxygen, and that's going to give me the number 4.63. All right, so again, this actually does give me a ratio. Okay, but the ratio is not whole number, so I need to make this into a whole number ratio. Okay, and the way we do that, the next step is all I do is I divide both numbers by the smallest one. So that would be 1.85. 1.85 is smaller than 4.63. So for nitrogen, I'm going to go 1.85 over 1.85. That's 1. For oxygen, I'm going to go 4.63 over 1.85. And that gives me a number that rounds to 2.5. All right. Now, this is a situation we've not run into just yet with our critical thinking practice we did earlier. So I did this division, and I still don't have whole numbers. Right? We don't put fractions or decimals in our formulas. Okay? So simple enough, right? This is a 2.5. This is a 1. So all I'm going to do is I'm going to double it. I'm going to make this 2. And if I double 2.5, I get 5. So my empirical formula would be N2O5. Right? So that is my lowest whole number ratio. So again, first step is to divide the percent composition by the mass. All right? Percent by mass. Okay? Then you divide by the small. Right? Divide by mass. Then you divide by small. Multiply till whole. So you divide by the percent by the mass. You divide by the small one. All right. If it's not a whole number ratio, you just multiply until it's whole. In this case, multiplying both by 2, we get whole numbers. That is my lowest whole number ratio. Next one. What is the molecular formula? Oh, we got to go one step farther on this one. Right? Right? So molecular formula is taking our empirical formula, our ratio, but then actually figuring out what the actual numbers of each one is. So remember, an empirical formula is our lowest whole number ratio. So in the case of NO2, right, That just means for every 1 nitrogen there are 2 oxygens, but that could emerge as NO2 or N2O4 or N3O6 or N4O8, right? There are lots of ways we can end up with that ratio of 1 to 2, right? We need to figure out which it is, right? Or is it even a higher number? So we'll figure that out. So all we do is we take the mass of compound over mass of empirical formula. All right? So in this case, we have the mass of the compound is 138. Okay? And the mass of the empirical formula, so 1 nitrogen plus 2 oxygens, right? That gives me 46.01, right? And then what I get if I round it off to a whole number is 3. So that means, okay, all I'm going to do is I'm going to take this factor of 3 and I'm going to multiply it by the subscript. So I have NO2, right? I'm going to multiply that by 3 and that by 3. So that what I get is N3O6 is my molecular formula. So it is that guy right there. All right, number 6. We are almost done, you guys. Number 6, we have compound contains 64.3% carbon, 7.14% hydrogen, and 28.6% oxygen. I think this is our first one with more than 2 elements present. But the process is the same, so ain't no thing. All right? So we want to do the empirical formula. So again, right, we're going to divide by mass. Then we're going to divide by small. Then we're going to multiply till whole, right? Step 1, 2, and 3 for this part. Okay? So first of all, we're going to divide each percent by the mass. So I'm 64.3% carbon, right? So for carbon, we're going to go 64.3 over the mass of carbon, which is 12.01. And that gives me 5.35. Right? We are 7.14% hydrogen. So for hydrogen, it's going to be 7.14 over 1.01. And that gives me 7.07. And then for oxygen, we have 28.6% over 16.00, and that gives me 1.79. All right, so I divided by mass. That's step 1. 12.01, 1.01, 16.0, those are the masses of those individual elements. And that gives me these numbers. Step 2 is divide by small. Our smallest one is 1.79. So we're going to go around and divide each of these by 1.79. Right? And that gives me a ratio of 3 to 3 to 4, and then 1. So what that means is my empirical formula is going to be C3H4O. We have 1 oxygen. All right? So that is my empirical formula. That just means for every 3 carbons, there are 4 hydrogens and 1 oxygen. All right, so the molecular formula is going to be some manifestation of that particular ratio. All right, but again, that could be C3H4O, or it could be C6H8O2, C9H12O3. There's all of those are the same ratio, same empirical formula. We're going to use this number right here to figure out which one it is, and all we're going to do, right, for this one is. Oh, by the way, I didn't have to do this multiply till whole because 3, 4, 1 is already a whole number. All right, anyways. So molecular formula for this compound is 448. So we're going to take 448, which is the mass of the compound, divided by the mass of the empirical formula. So 3 carbons plus 4 hydrogens plus 1 oxygen is 56.07. When I divide, I get approximately 8. All right? So what that means is I'm going to multiply the 3 and the 4 and the 1 by 8. All right? So 3 times 8 is 24, so C, 24. 4 times 8 is 32, so H, 32. 8 times 1 is 8. All right, so again, lots to remember there, but with practice, you guys will get this. Last but not least, we have a certain compound contains 26.35% carbon, 3.30% hydrogen, 70.35% oxygen. If the molecular mass of this compound is 819 atomic mass units, what is the molecular formula? So we're doing all this in one shot. Okay? So first we need to figure out our empirical formula, and then we can go to our molecular formula. All right? So to get our empirical formula, we're going to follow the same 3 steps. 1, divide by mass. And then 2, divide by small. And then 3, when I divide by small, if I don't get whole numbers, we're going to multiply till whole. All right? So let's go through this. We got carbon, hydrogen, and oxygen again. So carbon, we're going to go 26. All right. For carbon, we're going to go 26.35 over 12.01. And that is going to give us 2.194 with sig figs. Hydrogen is 7.14 over 1.01. Excuse me. I'm looking at the wrong question. Hydrogen is 3.30% over 1.01, and that gives me 3.27. And then my oxygen is going to be 70.35 over 16.00, and that's going to give me 4.397. Okay? So I just divided by the mass. Next is I'm going to divide by the my smallest number is this one. So I'm going to divide each of these by 2.194. And 2.194. And what I get with that one is a ratio of 1 to 1.5 to 2. All right? So I divided by the mass. I divided by the small. Now, this is not a whole number. So what I'm going to do is I'm going to multiply each of these by 2 to start. So I'm going to make this a 2. This is a 3, and this is a 4. Now I have whole numbers by doubling each of those. So my empirical formula is going to be C2H3O4. All right? That is my empirical formula, right? So we are nearly there. The last thing we're going to do, right, is step 4. Going to divide mass of compound over mass of empirical. Okay? So the mass of the compound divided by the mass of the empirical formula is going to give me a number. So we're going to do this. We're going to go 819 over the mass of C2H3O4, so 2 carbons plus 3 hydrogens plus 4 oxygens gives me a mass of 91.05. And that is going to give me basically 9 when we round. Okay? So that means I'm going to multiply my 2, 3, and 4 by 9. So if I go 2 times 9, it's going to be C18. Right? My 3 times 9 is going to be H27. And 4 times 9 is going to be O36. That is a big stinking molecule. All right? So these 4 steps, right? First, all we know is a percent composition and a molar mass, right? We have to first divide the percent by the mass of the element. Whichever of those numbers ends up being smaller for each element, we divide each one by that. So divide by small. If we're already at a whole number, we could skip step 3. That's okay. If we don't have whole numbers, just usually doubling them or tripling them will take care of that for us. Okay? That gets us to the empirical formula. If we know the empirical formula, we just divide the mass of the compound by the mass of the empirical formula to get a number. We multiply the subscripts of the empirical formula by that number to get the molecular formula. Lots to remember, as I said. All right, you guys keep after this.